Hi folks, we're going to take a look at number 8 from page 233. So here they want us to find all the points where the tangent to this curve is horizontal. So in other words, we have to find the points where the derivative of this function is going to be equal to 0. So let's start by finding the x values that make the derivative equal to 0. So we'll start by finding the derivatives. So y prime is equal to, well, here I see a product of two simpler functions, so x squared times e to the negative x, so I'm going to have to apply the product rule. So let's start. Derivative of the first function is 2x, then we're multiplying that by the second function, e to the negative x, and then plus the first function, x squared, times the derivative of the second function. Now here we're going to have to use a chain rule because we don't just have e to the x, we have e to the minus x. So negative x is going to be our u. So derivative of e to the u is just e to the u, so e to the negative x. And then we have to multiply that by the derivative of negative x, and that's just equal to negative 1. All right. So again, we said we want to determine horizontal tangents, so that means the derivative is going to be equal to 0. And so now let's start simplifying this expression. So I'd like to have it in factored form, since I'm trying to find where it's equal to 0. So I'll start by factoring out this common factor of e to the negative x, and I also see that I have a common factor of x. All right, so I can factor out x, e to the negative x, and then let's see what we have left. So here we just have 2. Okay, here we've got negative 1 times, well, we have one of the x's left over, so 2 minus x. All right, and now we have it in exactly the form we want because it's in factored form. So 0 is equal to x times e to the negative x times 2 minus x. So what's the first possibility? Well, if x is equal to 0, the whole thing will be equal to 0. E to the negative x could be equal to 0, but this is where we remember that this can't happen. An exponential function is never equal to 0. So from here, we have no solution. Okay, and lastly, 2 minus x could be equal to 0. In other words, x is going to be equal to 2. Okay, so there's two x values that make the derivative equal to 0, but since they're looking for the points, we need to find the y values. Okay, so y at 0, well, that's nice and easy. 0 squared times e to the negative 0 is just 0. And then here, y at 2. So let's see what that's equal to. Well, it's 2 squared times e to the negative 2. So I'm going to rewrite that as 4, and since this is a negative exponent, I'll bring that to the denominator. So 4 over e squared. And so our final answer, the 2 points that we're looking for, are just going to be 0, 0, and 2, 4 over e squared. All right, so just to recap here, they're asking about some information about tangents, so we figure we're going to be working with the derivative, and since we're looking for horizontal tangents, we're looking for the places where the derivative is equal to 0. So again, apply the product rule and the chain rule as needed, and just be sure you check the question. It's not just asking for the x values, but it's actually asking for the points, hence we needed to determine the y values. All right, that's it for this one.